All right, this is your review for activities 4 through 6. Also helps you to review for the second embedded assessment in Unit 1 as well as the Unit 1 test. So the first concept that we looked at was piecewise functions. So I'm going to look at number 1A, the very first problem in your review set, because this reviews both how to graph piecewise functions as well as how to list the domain and range. So two major concepts all rolled up into one problem. So in 1A, this was your function right here. It wants us to graph it. It wants us to list the domain and range. Now remember, it says inequality interval and set notation, and we had discussed multiple times that we're not learning set notation, so you can just leave that one off. So inequality and interval only for our class. So as I look at both of these pieces, both of them are linear and neither of them is a constant. So I'm going to use my T-chart method here. So I'm going to make this my top function. I'm going to use red for. So I always label which one's top and which one's bottom. So that way when I can't color code, it's easy for me to go back and look. So my table has to start with whatever my breaking point is. So in this case, -1, and it needs to follow the restriction. So this says less than, so the other x's that I pick here need to be less than -1. So I picked -2 and -3. Now I'm going to plug them in to find the associated y values. So -3 times -1 is 3. Take away 4 is -1. Then I plug in -2. -3 times -2 is 6. Minus 4 is 2. -3 times -3 is 9. 9 minus 4 is 5. So here I've got 3 points for my top. The other thing that I need to make note of is whether this very first point only is going to be open or closed, because I look at the restriction. It has no equals, so that means this dot is going to be an open circle. So then I'm going to look at my second table. So this is going to be my bottom function. And again, it needs to start at the breaking point. So start at -1. The restriction says greater than, so bigger than -1 is 0 and 1. And then I'm going to plug those in. So if x is -1, oh, this is just x, so that's -1. When x is 0, f of x is 0, because f of x equals x. This one is 1. I look and I see that this one should have closed. So now I'm going to go plot my points. So using red for my top function, I had an open circle at -1, -1. So -1, -1, open circle. Then -2, +2 is right here. Remember, all the other circles are closed. It's only the first one that we look at open, closed. And then -3, +5, which is up here. So remember to connect from the breaking point on. So I start at the breaking point and then connect this way. So there's my first piece. Then I switch to my second piece. I have a closed circle at -1, -1. Well, -1, -1 is the exact same point. We've talked about this closed trumps open, so I'm going to fill it in here. That should now be a closed circle. Then 0, 0, 1, 1, start at the breaking point and connect. So here is what my graph looks like for 1A. So that's one of the major skills that we listed when we unpacked the embedded assessment, being able to graph a piecewise function. So the second skill is being able to list the domain and the range. So remember, it said inequality and interval notation. So I always do interval notation first. The order is not important. But remember, on domain, we say look left first. So I start on the right side of the graph and I start looking, even touching with my finger if I want, as I move left. And I ask myself, are there any x's that I can't touch? Is there any stopping point as I move to the left? Well, there isn't, because this arrow means I keep going. So that means there's no restriction on the left side, which means I use -infinity. After I look left and get that value, then I look right. So I start on the left side and do the same thing, but moving in the right direction. As I move to the right, I also have an arrow, so there's no limit to the x's I can choose. Since it's on the positive side, that's positive infinity. The order is important. It has to be least to greatest, so the left side has to come first, then the right side. Now, that's interval notation. Inequality notation, same thing, except you use the sandwich. Our domain variable is x, so it looks like that. For my range, I look down first, so start at the top of your graph and start moving your finger down and ask yourself, is there any place where I no longer have y's? That answer is yes, I don't have any y's down here. This point right there is the last y value I can touch. So that is my minimum. We look down first, that value of y, because range is y values, outputs, is -1. So it includes, because it's closed, so that means it's a bracket. So as I looked down, the minimum was -1. Then I look up, so I start at the bottom of my graph and I look up. Are there any y's that I can't touch as I move up? That answer is no, it has an arrow. It keeps going, so it gets an infinity. Now, think about what this means. Inequality is less than greater than. We are saying that my y values start at -1 and get bigger. So we say y is greater than or equal to -1 because it starts at -1, including it, meaning equal to, and gets bigger, which is my greater than sign. So those are your answers there for 1A. Number 2 asks you to determine, let's see what the actual wording is here so I don't mess it up. Explain why the graph below does not represent a function. So you can see it here. So we did this in lesson 4.1. And this was when we talked about the vertical line test and we talked about the definition of function. You can explain it either way. You can either say it is not a function because it fails the vertical line test. Here, right here is where it would fail. Oops, I don't want to highlight anything. Because if I draw a vertical line here where x is -2, it hits the graph twice. So you can either say that it fails the vertical line test, so therefore is not a function, or you can use the definition, which the definition says that input -2 has 2 outputs. Again, the definition of a function is each input has exactly 1 output. So here, my input of -2, there's 2 different outputs. It could either be 2 or it could be -2. And so that's not allowed. Each input can only have 1 output in order for it to be a function. So either of those answers are perfectly acceptable. You can either explain using the vertical line test or you can explain using that definition of functions and the input-output. Okay, so that covers domain and range, piecewise function. Then next I would like to look at number 11A, where you are writing a step function. Remember that a step function is a specific type of piecewise function. It's like the one that you graphed here in 10A because all the values are constant in a step function. So when it's asking you to write a step function, immediately when you see the word step, you should know all my pieces are constants. So it says it costs $30 per day or $90 per week to rent a wallpaper steamer. So this is what you would use to take wallpaper off the walls. So if the time in days is not a whole number, meaning if you rent it for like 1.5 days, it's rounded up to the next greatest day. So meaning if you didn't return the steamer for 1.5 days, the charge gets rounded up as if it were 2 days. So to write a step function, it says for X days, use a domain of 0 to 7. So that means the only X's we care about are between 0 and 7. So what I did is, first things first, I set up kind of a little table for myself. And so I said, okay, if X is 0, I can't use that because it says not including 0. Because you can't rent something for 0 days. You're either renting it or you're not. So that was my first thought, is 0 isn't included. So then I said, okay, if I rent it 1 day, then it says it's $30 per day. So that's going to be 30. If I rent it 1.5 days, it bumps up to 2. And the value at 2 days, again, it's $30 per day. So 30 times 2, which gives you 60. For 3 days, again, and anything between 2 and 3 would go straight up to 3, would be 90. Now, $90 was the charge for the week. And it says customers are given the weekly rate if it's cheaper than using the daily rate. So that means for 4, the daily rate would be up to 120, but it says they're going to be given the cheaper value. So all up through 7, the value is going to be 90. So that tells you how to write your step function. So we say f of x is either going to equal, because they're all constants, so it's either going to be 30, or it's going to be 60, or it's going to be 90. So then you have to write your domain restrictions. Whenever you write a piecewise function, 30 if x is between 0 and up to and including 1. So meaning if you run it for a half day, 3/4 of a day, or a full day, the charge is going to be 30. 60 is going to be the charge if it's bigger than 1 and less than or equal to 2. So between 1 but not including 1, because 1 is included here, and then up through and including 2. And then our last, of course, the value or the cost to rent is going to be 90, starting above 2. So if it were 2.5, it would still get charged like 3 days, which is going to be 90. And again, it said use a domain of 7. So even though technically this guy could go to infinity, it's because of the directions that we put the 7 here, because it says use a domain of x between 0 and 7. So the last part of activity 4 was our absolute value parent graph and transformation. So we're going to look kind of at that next. Remember, really important what we had done in class and what I gave you on the handout, that our general equation, that you know in this general equation what all of these variables control transformation-wise. So again, we kind of did this step by step in the notes. We had looked at one change at a time. But again, in general, if it's outside the bars, it's going to control something vertical. So K controls your vertical shift. Again, it's on your paper, but plus means you go up and minus means you go down. A is also outside the absolute value bars. That controls your vertical stretch and shrink. Remember that it's a stretch if the absolute value of A is bigger than 1, or shrink if the absolute value of A is between 0 and 1. Again, you don't necessarily have to memorize these. If you can graph it and then tell whether it's a stretch or a shrink, that's the other way to go as well. Remember that the variables that are inside both control horizontal movement. So H controls your horizontal shift. If it's plus, it's left. And if it's minus, it's right. Your B value controls horizontal stretch and shrink. It's a stretch if B is between 0 and 1. It's a horizontal shrink. The absolute value of B is bigger than 1. So remember also on those horizontals, this one gets a star because the factor is always the reciprocal. So what you see in the equation, when you list the transformation, you say horizontal shrink by factor of 1 over whatever B was, and that's only for horizontals. Again, notice some relationships here that we've already talked about. The H and the K that control the shift, those are both added or subtracted values. So outside controls vertical, inside controls horizontal. Added or subtracted controls shifts, and then multiplied, which is your A and your B, this controls the slope. So A and B values both change the slope to whatever that number is. Okay, so again, it does you absolutely no good to listen to this if you don't have these memorized. You need to know these. Know what K, A, H, B all do. Also, the last one, remember that we end up with a reflection in the x-axis. Excuse me. When A is negative. We don't care if B is negative. That does nothing. But a reflection happens if A is negative. Okay, so if we want to look at one of the problems here to practice a little bit. All right, so let's look at number 17b, where you started out with the equation. It said g of x equals 1/3 times the absolute value of x plus 2. And it asked you to graph the transformations, identify the transformations in 17 there. So it does not matter which one you do first, whether you graph first and then list the transformations or list them first and then graph. It's whatever works for you. That is fine with me. So on these ones, I'm probably going to list the transformations first. So again, we're just looking, how is this different than this? Because this is the parent. Everything that's different represents a transformation. So what I have here, first I notice that I have a plus 2 on the end. So if I look at my little key, and again, you can't look on the test, so you've got to know them, but this is a K value. This is on the outside and it's added. So this means that that is a vertical shift up 2 because it was positive. So I took care of the 2. The only other thing that's different is this 1/3. So that 1/3 is multiplied and it's in front. So that means it's an A value. So it's either a vertical stretch or a vertical shrink. Again, if you're not sure and you want to wait till after you graph it, that's fine. I do know these for vertical, and I know that because it's between 0 and 1, 1/3 is between 0 and 1, that's going to be a vertical shrink. So I'm going to say vertical shrink by factor 1/3. So now I need to graph it. Again, if you preferred to graph it first, that's perfectly fine. It doesn't matter. So this is my coordinate plane. My first transformation, remember, when you go to graph, the first thing that you should graph is the vertex. And the vertex location is based upon your shift values. So the only shift that I listed here was for vertical, up to. So to plot my vertex, I'm simply going to go up to from the origin, which is where the parent graph's vertex is. So I went up to, there's my vertex. So vertex always comes first when you're graphing. After the vertex, then you need to find the slope. So the slope is A or B. So for the vertex, we look at H and K values. And for the slope, we look at A or B values. So I have an A value of 1/3, so that means my slope is 1/3. Now, last thing I need to look is direction. This is based on, is there a reflection? In this one, reflection was not a transformation that I listed. So that means this one's going to go up because it's not flipped. So using a slope of 1/3, I go up 1, right 3. Up 1, right 3. Up 1, left 3. Up 1, left 3. And then connect. Again, if you preferred to graph first and then describe the transformation, you could know that that's a vertical shrink, because remember that vertical means you're up and down. Shrink means to push. So if I push something with my hands coming from up and down, it's going to squish it out wider. It's going to make it fatter, and indeed, this is certainly fatter than my parent graph. And so that's what that looks like. Remember that if you're asked to work backward, which you are in 16 and 19, you're given the picture. The process is the same. Look where the vertex is, because how much you shifted tells you what H and K are, and then you can put them into the equation. Then you should count your slope. How much did you go up or down, and how much did you go left or right? The slope is either an A value or a B value, your choice. And then finally, which direction did it open? If it opened down, you know that you need to have a negative in front. If not, then it should be positive. So that was the last part of activity 4. Then we moved on to activity 5, where we talked about function operations and function composition. So a lot of problems in here having to do with the different operations, as well as I gave you some more practice with writing your own functions. So again, I'm just going to cover the basic concepts here. I'm not doing every problem, but I am going to cover all the basic concepts. So the first basic concept in 5.1 was that we needed to know how to perform function operations, such as addition, subtraction, multiplication, and division. So I'm going to look, for this one, I'm going to look at, let's see, I'm going to look at 9. So this is start of activity 5, so the second set of problems. Number 9, in A and B, you wrote the functions. So you can see on your answer sheet what the functions were supposed to be, and hopefully those make sense for the length and width. So performing an operation means finding either addition, subtraction, multiplication, division, composition. So in C, it asks you to find L times W of X. Again, this little tiny dot represents multiplication. So this notation is telling you to take L of X, which is this, and multiply it by W of X, which is this. Again, we've gone over this in class. This is a binomial times a binomial. So that means that I need to FOIL here. So when we do that, F for first, so 60 times x is 60x. O for outside, so 60 times 50, which gives us our 3,000. I for insides, x times x, which is x squared. And then L for lasts, x times 50, which is 50x. So then combine like terms, put it in order. So x squared plus 110x plus 3,000. So that then is our answer for C. That is an example of function multiplication. Now let's do one more of the simple operations first. So let's look at number 10. I'm actually going to look at it on here. So number 10, given that P of n is 4n squared plus 4n minus 6, and Q of n equals n squared minus 5n plus 8, find P minus Q of 3. So that means first we need to find what P minus Q's function is. So if I go back to my other screen here, and I take my P, which is 4n squared plus 4n minus 6, and I'm going to subtract the Q because it says P minus Q. So n squared minus 5n plus 8. Remember that on subtraction, you have to distribute the negative. So this becomes minus n squared plus 5n and then minus 8. So then combine like terms. Here's two squared terms, so 3n squared. Then here's some plain n terms, so it gives me a total of 9n. And then my constants, negative 6 and negative 8, give me a negative 14. So P minus Q of n is represented by this function. Now, that's not what the question asked for. Finally, you have to pay attention. It says find P minus Q of 3. So that just means plug 3 into this guy here. So when I go back and I put 3 in, so 3 squared times the 3 plus 9 times 3 minus 14. So order of operations, 3 squared first is 9. 9 times 3 is 27. 9 times 3 still 27. Minus 14. Addition and subtraction we do from left to right. So 27 plus 27, then minus 14, which gives us a total of 40. And so then there, that was answer C for number 10. So again, it may be multiple choice, but you have to have work because it's asking you to find functions that you can't find in your head. All right, so last thing we need to talk about for activity 5 is function composition. So for function composition, we're going to look at the last couple problems where in 23 through 25, above that, they told you f of x was x squared. They said g of x was x plus 5. And they said h of x was 4x minus 6. So function composition here. I'm going to look at 23 and then also at 25. So 23 asked us to find f of g of x. Remember that this is the composition symbol. It's not multiplication. This means to compose the functions. So first step, start on the inside with g of x. So I need to make a substitution. In place of g of x, I'm going to put its rule. So now I have f of x plus 5 because that's what g of x is equal to. Remember what this means. F of anything means plug this in place of the variable in the function that has this name. So the function named f is right here. So the variable was squared, so it was variable squared. So now in place of the variable, I'm putting whatever's in the parentheses. So in this case, x plus 5. Again, we talked about this exact thing in class. you have to FOIL here. X plus 5 squared means x plus 5 times x plus 5. So first, outer, inner, lasts. So x squared plus 5x plus 5x again plus 25 is how I got my final answer of x squared plus 10x plus 25. Now I'm going to look at number 25, which was f of h of x. So again, that means the same thing as this. So h of x goes on the inside. So f of 4x minus 6, there it is, goes in. So now take that and put it into my f function. So 4x minus 6 is what is getting squared. Again, FOILing here, it's 4x minus 6 times 4x minus 6. So firsts are 16x squared. Outsides and insides both give you 24x, and lasts give you a plus 36. So that's how I got 16x squared minus 48x plus 36. All right, so that covers our function operations. Very last thing that we need to look at is activity 6, which was inverse functions. So, important things that you learned about inverse functions. First of all, the definition is that f of f inverse of x equals x, which equals f inverse of f of x. Again, this is fancy math stuff that basically says that they're going to undo each other. So when I perform whatever this inverse function is on x, and then take that answer and put it into my original function, that it undoes whatever the inverse did, because I get back exactly what I put in. So by definition, inverse functions, both compositions, which is what these are, of the original and the inverse, should equal out to x. So that's our definition. The other properties that we should know about inverse functions is that the domain and range of inverse functions are switched. And final property that you should know is that their graphs are reflections over the line y equals x. So a couple examples that we're going to look at here with inverses. Number 9 is what we're going to look at first here, mainly because it's pretty quick, but it's an example of one of the properties. So given f of 1 equals 5, which of the following statements must be true? So obviously on the answer sheet you can see what the answer is, but I want to make sure that you understand why, because this all says f inverse of something. So remember that inverses have to undo each other, and the domain and range are switched. So it says f of 1 equals 5. So that means in the original f of x function, when x is 1, y is 5. And what this is asking is what's true about the inverse. So if we're looking at the same table on the inverse, f inverse of x, remember we switch the domain and the range. So meaning if x is 5, y would have to be 1. So then we're looking to see which of those says that. Input 5 is output 1. So input 5 are these two. The only one that has output 1 is D. So I wanted to make sure you understood that difference there. All right, we're going to look at number 14 next to kind of do the algebraic stuff that we were talking about. Again, it's multiple choice, but you can't get the multiple choice answer without the work. So when I look here, it says, what is the inverse of P of t, which P of t is given as 6t plus 8. So to find an inverse function, our first step is always to put y in place of our function notation. So y equals 6t plus 8. Then it's to switch our variables. So usually we have y and x. Here we have y and t, which is fine. Just switch them. So t equals 6y plus 8. Third step is to get y by itself. So subtract 8, t minus 8 equals 6y. Then y is still not alone. I need to divide. So I divide both sides by 6. So now I have y equals t minus 8 over 6. Last step is to put it back in inverse notation. So P inverse of t instead of P of t equals, and then whatever's over here, t minus 8 over 6. So if we look at the choices, that choice is choice C. 15 says use the definition of inverse to determine whether or not each pair of functions are inverses. Now the key here is use the definition. It's being very specific about how you have to do this. So this was number 14 here. So if I look at 15a, again, my originals, I have f of x equals 5x minus 3, and then I have g of x equals x over 5 plus 3. So in order for these to be inverses, again, the definition, if we scroll back up to what we talked about here, is that both compositions have to equal x. So meaning, if I do f of g of x, I should get x. And if I do g of f of x, I should get x. So it doesn't matter which one you start with. I usually start with whichever function comes first on the outside, but it certainly doesn't matter. So again, this goes back to function composition and what we learned. G of x is on the inside, so that means I'm going to put this, oops, moved my screen, didn't mean to do that. I'm going to put this expression on the inside, so f of x over 5 plus 3. Again, over and over and again, we say this notation means to put this in place of the variable in my f function. So my f function was 5 times the variable minus 3. Now I'm going to put this in place of the variable. All right, now I just need to simplify. So distribute by 5. 5 times x over 5 is just x. 5 times 3 is 15, and then minus 3. I get x plus 12. If they are inverses, I'm supposed to get x. So on my first composition, I did not get x, which means no, they are not inverses, because my first composition did not work. Because for explanation, you can just say f of g of x didn't equal x, and that's enough. All right, very last problem, dealing with the last property of our inverses here. We're going to look at number 20, where it asks you to actually graph the inverse. So it gives you the function and asks you to graph the inverse. So you need to pull the actual ordered pairs from what you see here. So I see an exact point here at 0, -1. So if I see a point at 0, -1, that means that on my inverse, I should see a point at -1, 0. So right now, I'm just going to record some points, and then we'll graph them once we have a more complete looking list, because again, we have to have the whole thing. So -1, 0, because this was 0, -1. The next exact point I see is right here. That is -1, -4. So that means switch the input and the output. Instead of -1, -4, it's -4, -1. Go back to the graph, find another exact point. Oh, here's one right here, 1, 2. So if 1, 2 was exact on my original, 2, 1 is on my inverse. this one up here probably is 2, 5, so I would say maybe 5, 2 is also on there. We can make sure that they fit the pattern. So plot them. -1, 0, right here. -4, -1, 2, 1, and then 5, 2. So there's the graph of your inverse. Again, if you look at that graph and look at the graph that's in the book, which I can replicate it in a different color here. 1, 2, 3, 4, right here. Something like this. You can see that the property we talked about does exist. The line y equals x is this line right here. And those graphs are indeed reflections over the line y equals x. So I know that I did it correctly. All right, that covers all your major concepts on activities 4 through 6. Happy studying.